In this video, we're going to focus on simplifying algebraic expressions as well as evaluating algebraic expressions when we know the value of our variables. But first, let's simplify some expressions. So right here, I have the expression x squared plus 5x plus 2y plus 7x squared. And the entire idea behind simplifying algebraic expressions has to do with combining like terms. So if we look what we have here, I have an x squared, an x, a y, and an x squared. I'm going to underline common terms. So I'm going to underline the x squared, and I'm going to underline the 7x squared. And for this example, that's all I'm going to underline, because x and y are not the same, and they're not the same as x squared either. Now that I have some common terms, I'm going to combine them. I have 1 x squared, and I'm going to add to it 7 more. 1 plus 7 is 8, so I have 8 x squared, and the rest of the expression stays exactly the same, because I can't do anything to combine the 5x and the 2y until I know what their value is. So my answer is 8x squared plus 5x plus 2y. And that's a terrible looking plus sign, but that's what it is. Okay, let's try a different one. Here we have 4x plus 3y minus 6x plus 8y. And just like last time, I'm going to underline my common terms to start off with. So I have a 4x and a negative 6x. We're going to want to treat that as a negative 6x. And then I also have a 3y and an 8y. So I have x's I can combine, and I have y's that I can combine. Let's start with the x's. I have 4x minus 6x. That's going to give me a negative 2x. And if you want to, you can cross out the terms as you use them so you don't accidentally use them a second time. Then I have a 3y plus an 8y. So I'm going to add those together and get a plus 11y. And here I have simplified my algebraic expression. But what if we are involving the distributive property or just a little more going on with our examples? Let's see how we would handle it if it's a little tougher. Alright, for this example now, look at what we have. We have b times the quantity 5a squared minus 2a minus 11a squared b plus 2ab. And at first glance, we do not have any common terms. I have a b, an a squared, an a squared b, and an ab. So nothing is the same. But I have a distributive property set up right here. I can multiply b into these parentheses, and maybe we'll get some common terms there. So let's do that. I have b times 5a squared, and that's going to give me 5a squared b. Then I have b times a minus 2a, and that's going to give me a minus 2ab. And I haven't done anything to the rest, so we'll leave that as minus 11a squared b plus 2ab. Alright, now it looks like we have some common terms, and it's all thanks to doing our distributive property here. I have an a squared b, 5a squared b, and I have a minus 11a squared b. I have a negative 2ab and a plus 2ab. Now, generally we want to go with the highest degree term first, so that's our a squared b terms. So I have 5a squared b minus 11a squared b. And that's going to give me a negative 6a squared b. And I use them both so I can cross them off. Then I've got a negative 2ab plus a positive 2ab. and that just becomes 0. They cancel each other out, so these go away, and our answer here when simplifying this is just negative 6a squared b. Let's try one more. I'll put the example up. You can try it on your own first, and then we'll go over it. Alright, for our final example, and the one that you're going to try on your own, we have negative 3 times the quantity 2x minus xy plus 3y, and quantity, minus 11xy. And we want to simplify this down. So why don't you pause the video, give it a shot, and we'll give it, and then hit play when you're ready, and we'll go over the answer. Alright, so you want to distribute first, just like we did in our last example. So when I distribute, I'm going to have negative 3 times 2x, which is negative 6x. I'm going to have a negative 3 times a minus xy, which we're going to treat as negative, so it's going to be plus 3xy. That was a spot where we might have made a mistake, because we want it to be a plus from a negative times a negative. Then I've got negative 3 times 3y, so that is a minus 9y. And then we have our original ending, which is negative 11xy. So what common terms do we have? I have a 3xy and a minus 11xy, and that's it. Can't do anything with the negative 6x, can't do anything with the negative 9y. So we will combine our like terms, positive 3 minus 11xy, and that's going to give me a negative 8xy, and then everything else is going to stay the same, minus 6x minus 9y. And there's our answer. So there's how we would go about simplifying our algebraic expressions. But that's not all, because what if we're not just told to simplify, but we're told what x and y are equal to? Let's take a look at an example like that now. So here we have the expression x plus 3xy minus 2y for x equals 4 and y equals 7. So we're going to take this expression and we're going to substitute the values of x and y into it. So instead of starting with an x, we'll start with a 4. Plus 3 times x, which we said was 4, so I'll throw a 4 in there. And then we're timesing that by y, which we're told is 7. So I'll throw a 7 in there. Minus 2 times y, which was 7. And now we don't have any unknowns. We can actually figure out what this equals. We can work through it and get a final answer. So, following the order of operations, we want to multiply first from left to right. So, can't do anything with the 4. The 3 times 4 times 7. Well, I'm going to multiply the 3 times the 7 and get 21. 21 times 4 is 84. So this is going to be plus 84. Then, over here, I've got minus 2 times 7. So that's going to be a minus 14. And we can add all of this up. 4 plus 84 is 88. Minus 14 is 74. And there is our answer. We simplified our like terms because, we didn't simplify our like terms. We simplified our algebraic expression because while they didn't have any like terms, we knew the values of our variables. So we'll try one more example like this, and that'll be it for this video. Alright, here for our final example we have x squared y minus xy squared plus 3y for x equals 2 and y equals 5. So, just like we did in the previous example, we're going to replace all of our x's, this one and this one, with 2, and all of our y's with 5. Now, the thing we have to be careful of, though, is the exponents. Notice where the exponents are attached. This exponent of 2 is attached to this x. This exponent of 2 is attached to this y. So we want to make sure that when we substitute the values in, we keep the exponents with the values they go with. So we've got 2 squared times y, which was 5, minus 2 times y squared, so that's 5 squared, plus 3 times y, which was 5. So I have substituted all of my values into the expression. And now all we got to do is work it out. Follow your order of operations. 2 squared is 4 times 5, minus 2 times 25, because of 5 squared, plus 3 times 5. Okay, now we can follow our order of operations again and do our multiplication from left to right. So 4 times 5 is 20, minus 50, plus 15. And we can solve all of this. 20 minus 50 is negative 30, plus 15 is a negative 15. And there is our answer, negative 15. Alright, I hope you found this video useful. Good luck applying these in your math.